Hello, my name is Andrei Lopatenko. I'm VP of Engineering in Zillow. I'm leading search engines and NLP and conversational AI team. And this talk is about natural language processing at scale, how to build natural language processing systems, how to apply them for benefits of your business and customers, and how to do it at scale. The focus of this talk will be how to implement systems. So there are a lot of articles how to train models, how to deploy models, mostly on training models. The focus of this article, of this talk, is about building systems and how to build them at scale within your organization to apply very different business cases, and how to build efficient systems, how to build efficient teams, and then how to apply this with big benefits for your organizations. What does it mean NLP at scale? So there are multiple dimensions of scale. I will focus how to build systems which can be applied to multiple very different business tasks. There are very different technologies, very different serving scenarios, and also to build for systems for high loads. And high loads means number of users, requests, number of documents to be processed, a number of documents to be processed and streamed, and so on. I will focus mostly on system aspects of building NLP systems rather than just training high accuracy NLP models. There are a lot of articles how to train high accuracy NLP models. Why I'm talking about this? I am in NLP for last 16 years. I started my career in Google, where I was working on NLP for search. Since that time, I was working in Apple Maps search. I was working in Walmart search, eBay search, currently in Zillow. I was always working on various applications of NLP to very different search engines, different domain areas. So I have 16 years experience in building NLP systems, and I will share my experience how to build them in good way and efficient way. Motivating examples. Number of motivating examples why NLP is good, why it's useful for, right? Because there are a lot of media recently about using NLP, mostly about dialogue systems, but NLP is like well known and used for high like $1 billion scenarios when it serves business. Customer-facing online systems such as search systems, for example, web search, map search, real estate search, e-commerce search, and so on. Right. Recently, it was several articles how BERT was used to improve Google, but like NLP used to improve search since like early search engines since 2000. There are a lot of old NLP techniques: synonym expansions, term weighting, shallow parsing, phrase chunking, query classification, many others they used to drive majority of search experience online since early 2000s. They're applicable to any search engine in any domain area, commerce, apps, whatever, media. NLP radically improves quality of search results, and it's well known since the early 2000s. There are a lot of recent improvements with applying deep learning. NLP, for example, deep NLP in LinkedIn search article, but so NLP like one of the major drivers of customer experience and business revenues of search engines. Another like customer-facing online systems, recommendation engines. Example from Zillow, right? Once you want to recommend similar items to user, how to understand this item is similar to item what user currently looking for. And NLP to extract to information about items to understand if they're similar is one of the useful engines to drive these use cases. And information extracted by NLP significantly improves recommendation quality. And like this another serving is use case of NLP when NLP is used to drive real systems. Another case, a business facing question answering system. So there are many systems when NLP is used to answer questions not from customers but from business agents. Just example, Bloomberg trade order management system. And there are a lot of cases when NLP is used either to answer questions from other unstructured information, large set of documents, or from structured information such that databases, when basically we don't assume that business engines will know SQL or any other structured query language. They ask queries in natural language, and NLP is used to map these natural language queries into database queries and extract information. Another case is analysis for conversations. It's very popular. Like still, any business, despite of success of dialogue systems, chatbots, still many businesses are based on customer to business or business to business conversations done by phone or through Zoom or any other sources. Can we understand how well this like phone calls are going on, right? If you call to customer support, did they answer your questions or not? Are this particular agent successful or not? What are trends? What customers want to know today versus they know tomorrow? How we have to train our agents to serve these customers better? And analysis of this multiple phone conversations. You can imagine any big business has like millions or tens of millions of minutes of phone conversations per month, or hundreds of millions, right? You cannot analyze them manually. NLP is very useful together with automated speech recognition to understand quality of conversations, quality of agents' work, customer trends. And Zillow, we built several systems to do this. You can go by these links to see examples. And this is another NLP use case. Customer support dialogue bots, chatbots. In Zillow, we built rental manager bot answering questions of rental managers. Very big success, both in customer satisfaction and business metrics, how it drives like conversion. Amazon customer support chatbot, another example. So this is another example of NLP-based systems which work very well for business and also very high for customer satisfaction of your customers. Item understanding, right? Once your system like imports a lot of information, how to map and structure information into structured representation of this information into some multidimensional representation systems, database. Zillow understanding of listings, Amazon or Walmart understanding of items from marketplaces are examples of such systems when NLP is used to understand unstructured information and map it into structured information. So as you see, there are multiple very different NLP use cases used to improve customer experience, used to improve business through different metrics, through customer conversion, through amount of revenue, by high conversion, and so on, right? NLP systems built for these use cases has high ROI if applied correctly, right applications, right technologies, right teams to build this. So these 6 use cases are mostly randomly. There are many other NLP applications, again, with bringing big benefits. And I wanted to show that applications of NLP are very different, not just dialogue systems as, again, a lot of media hype currently, but there are very different, very traditional NLP use cases serving customers and business for dozens of years. Most of media impact, media hype is about chatbots, but again, search, recommendation, personalization, item understanding, document understanding, better classification, information extractions, other very big NLP use cases, actually with much bigger revenues and profits than chatbots. There are multiple typical NLP serving scenarios, just like several typical, and there are many other online serving when user comes to your system, and you have to apply NLP to understand user query. And it's like typically you have hundreds of models to do this. You have hundreds of thousands of millions QPS, in some cases millions of queries per second. Very short latency requirements, one NLP serving scenarios. Streaming serving scenarios, you have multiple documents coming to your system, such as item descriptions, such as crawled web pages. You have to understand them on the fly. Like you might have millions of documents per day, depending on your system, or it may be small and millions of documents per day. Again, depends on system. Different latency requirements, high QPS, high items per unit of time requirements, and so on. And batch scenarios, when you have very large collections of documents, you want to process them in one time. So these 3 kind of different serving scenarios, and there are multiple others, but this kind of 3 perhaps the most popular one because they serve many business cases. So when you build an NLP system, it's not just about training the like output and other requirements. Is how to train models, create scientist workbench so that multiple scientists can work simultaneously on multiple business cases and train their models, how to collect and annotate data, how to deploy models from research into production environments, how to test models, validate models, monitor models for performance, accuracy, compliance, fairness, and monitor models, but actually you care end-to-end systems, right? You don't just care what perplexity of your language model, you really care how does it improve your spell correction model, and actually how the spell correction model corrects number of failed queries by customers, right? So like how to validate your models and the impact on end-to-end performance of the systems. Integrate models with in-streams of production data, and integrate your models with outstreams with business or customer-facing systems such that customers or business get direct benefits of your model. So NLP systems is not just about model training, but about whole this model end-to-end training models, serving them, so having data to train models, testing models, and so on. So those makes a big successful NLP systems. Majority of big business revenues and customer experience gains are not from the most recent thought NLP models, the best science, but from the best engineering. High performance, reliable, robust, scalable systems, integrated with, of course, your business and consumer applications not working in some research environments, building the systems monitorable, debuggable, right? And to make successful NLP products is like focus more like on building systems, building high quality system, robust perform systems, rather than just building higher accuracy models. And one system works and brings value, like one system integrated with business, with high performance and so on. The next steps typically is like, let's start polishing models, making high accuracy models and so on. But the first step is typically building NLP systems. Very like kind of high level of like blocks of the systems is scientist workbench, access to the data annotation tools, where data processing, data management, metrics tools, model training, where your scientists work to create models. Deployment tools, how to support CI/CD for NLP science cases, how to support continuous deployment of models into various deployment to various environments, model validation, model management, inference, how to serve these models in your productions, again, with very different serving environments, and integration with other business systems or customer-facing systems. As I would say, like at high level, there are three ways how you build NLP systems currently. Like it's very different how you would do 3 years ago or 5 years ago. So you would say like you can build cloud native systems. There are a lot of cloud blogs from AWS or Google or other cloud providers. You from scratch you write your system or using like low level open source, and hybrid you combine these two methods. Cloud native systems. There are multiple ways how to build cloud NLP systems. I will talk mostly about Amazon just because I know Google has a lot of other their own tools, Oracle has own tools, IBM has own tools. I will talk about Amazon just because of my knowledge. There are multiple high-level cloud NLP and ML services at Amazon and different levels. You can go either like using machine learning low-level scenarios, train models on them, or you can use high-level scenario like using comprehend and so on. Each of them has own advantage, disadvantage, right? Pros very fast to develop, prototype, and make working systems, low development costs, easy to integrate with other systems on the same cloud, like easy to operate, manage solutions. Cons, high cloud and compute cost, low flexibility in terms of model to develop and opportunities to develop high accuracy models. Typically, those systems go well behind SOTA models, which are recently deployed, recently developed. Performance is not maximally optimized. Integration with non-cloud systems requires a lot of efforts. This systems has a lot of ML ops and ops development. For example, Amazon has very big infrastructure to support your ML ops and ops. Again, it's easy to adopt the same cloud production environment, easy to build multi-environment deployment scenarios and so on. So if you go cloud native way, build from scratch, right? This is how what you do typically, and what I did multiple times 10 years ago, or maybe even 5 years ago. You build your system using either like going from really low level and building everything on your own, or you use some open source such as PyTorch serving, TF serving, Hugging Face transformers, invaluable library now, NLP environment to create your metric environments, or some other like if you build an NLP stack, there are like model serving, model training, annotations. There are a lot of open source available to each of those parts. You can reuse them, right? Going low level, you of course have more opportunities for optimization of accuracy of models, performance of systems, customization for your needs, and of course you have longer prototype and production development times and high operational cost to operate this, unless you don't have managed operation solutions. In some cases, it's necessary to do this way. For example, typically for online serving scenarios, you have very high load QPS requirements. Not always cloud solutions can serve for this, and you have to really go low level and build serving system at NLP, which can be optimized for particular hardware stack, which serve particular requirements, right? Specialized hardware and so on. So this is typical for very big, high-level serving systems. There is no available software on the cloud. But it's kind of extreme cases. In most cases, you don't need to go this way. Another way is to build mix and cloud and custom build systems. So you can build a lot of using blocks from cloud, which you don't want to repeat, and because actually people from AWS or Google do quite good job building their systems, right? They may be not optimized for some specific scenarios, but they're quite good generic systems. You can use them for those blocks, but for your blocks, you can use your system. And then you build kind of system based on different blocks, right? A process, so it's kind of combination between two previous cases. Pros, relatively rapid development and deployment. Cons, pros and cons, serving costs, in between two previous cases. As example, you can go by these links and check, like we built an NLP system in Zillow to analyze customer to business calls, to understand what customer insights we have built these systems. I would put it into this hybrid scenario when we build some blocks from cloud, and for some other parts we build our own blocks. And again, there are different ways how you're going to separate. Sometimes you build horizontal separation, like for example, you can build your scientist lab your own and use cloud to deploy to build inference out of the systems, while you can do vertical separation, like for example use low-level components from cloud and high-level components on your own. So there are different ways how you build these blocks. Again, there are multiple scenarios of deployment. You can use, like, you can use manage Kubernetes your own. So there are multiple trade-off points depending how you want to build your systems, what you really care about. So frequently, like, it requires still, even if you use open source, it requires a lot of your work. Like for example, if you use Kubeflow, right, it does not support all serving environments. Sometimes it requires a lot of work, or actually it does not support some serving environment which declares support, does not support so well as you expect of them. So you do have to go a lot of to open source and actually change it on your own. There are many other tools available like Kubeflow, Cortex, Hadrosphere, managing monitoring models. So there is quite abundance of open source to build like NLP systems at different levels, like as an experiment environment or model management or model validation or deploying models or serving models or tracking experiments and so on. There are a lot of open source which you don't need to repeat. You can use some of this while developing other systems on your own. And of course, there are also a lot of low-level systems like Kubernetes, of course, Istio, Prometheus, and so on. Again, like, there are different, like, depending what you want, there are a lot of open source libraries for that. For applied scientist workbench, you can build on top of Jupyter. You have ModelDB, you have TF model analysis, right? You have TM transform for training, data training. You have for serving multiple serving environments. So there are a lot of different blocks to build your systems. And it's not necessary to use like AWS or Google Cloud. You can use this open source to build your system. And what good, you have a lot of opportunity to go and modify for your needs. Again, like NLP is relatively, like, coming back to product and business. NLP is relatively new for many businesses. There is a lot of excitement and a lot of uncertainties and expectations what advantage we can get of building NLP systems for business. And to prove value, typically you have to iterate very fast, build systems fast, prove business value, and velocity of system building, velocity also how you can change the system very fast for new business scenarios, for new business cases. This is very crucial, right? So one of the key requirements, what I see in building NLP systems, is not again about training state-of-the-art models for some particular use case, but actually capability to iterate very fast on building systems for different needs, integrating with different needs, and also building and training very different NLP models for very different needs, right? So velocity is the key. And also, like, it's not just about proving your system for a particular use case. Also, business priorities typically change very rapidly, and you have to make systems which can adopt to business requirements very rapidly. That's why I find, like, kind of cloud native solutions usually has some advantage, because you can build on them very fast. You can very fast modify systems. You can also scales quite well by number of consumers, lines of business, other loads. Then once you build your system, prove the value for the business, create a trust relationship with business teams, you can move to other architectures when you can like allow a little bit more slow development, but you already proved the value, right? People trust you, it's well-funded, your systems. Then you can focus more like on performance, costs, accuracy, and so on. So my recommendation for many business cases is to build NLP systems fast using cloud-based environments, and then move to your own. Then you can optimize a lot once you prove value and build connections with that business. Trade-off, again, like everybody talks now about deep neural methods, but classical methods also has a lot of value. Frequently, deep neural methods, they have quite slow performance, right? And for many systems, you have to actually look if you get 10% model accuracy improvements versus 10% difference in latency. What actually really more important for your customers or for your business, right? So your system must allow multiple different serving scenarios, multiple different types of model, very different from recent, like like PyTorch serving some deep learning based transformer-based NLP models to classical, like CRF models or anything else, for you to experiment and iterate to find what's the best for your business. And it's very important to support system design to support very different solutions, but also organization structure, like such that we can iterate and play with different science scenarios, different engineering scenarios, and also build analytics and ROI assessment which can support and understand deeply like what models better for customers, what is it more important to have high accuracy or shorter latency time, what really makes different customer experience or business experience. System scalability, important part of the modeling, should be in the system by design, and there are multiple different scalability dimensions by number of human languages, right, or domain area languages, by the load, like QPS of a system, number of messages per second, amount of data in the batch, number of different models, and number of different types of models. You start with several models and then easily go to hundreds of models in production of thousands of models. Number of developers and scientists working simultaneously deploying new models, new types of data, and analyzing the experiments. Number of metrics, of course, also significantly expands as you build the systems. The amount of data and training and serving, the number of use cases, the number of deployments, number of business use cases you serve, and so on. Those are key parameters of system scalability and must be in the system by design. Very important, serving scenarios can be very different, but scientist scenarios typically quite the same. And very important to build good applied scientist workbench. If you save a lot of time for applied scientists on data processing, data access, data transformation, experimental time, you significantly improve velocity of your NLP work. So very important to build a good NLP lab, which allows scientists to share their metrics, share their test data, training data, to share the different models inside. Neural architectures is very important part of building successful NLP system at scale, when it will be used by multiple dozens of NLP people. MLOps, of course, is a very important part, right? You don't build system to publish an article with state-of-the-art result. You build a system to serve millions of users, customers per day or more, right? And support the frequent deployment of models as models improved and new models are deployed. Integration of NLP scientist workbench with production environment, such that scientists don't need to know details of deployments. They just build new models, say it's ready, it goes, validated, tested, goes to production automatically. So building MLOps for NLP systems is a key, big part of the success, such that scientists can scale, deploy best models without thinking about deployment. It will MLOps take care of them. It will validate models and so on. Monitoring for performance, incidents, exceptions, quality of models, part of the systems is an important part of successful NLP system. Monitoring what may go wrong. A lot of things may go wrong as you build NLP systems for production, right? Model performance, how your new models, I feel impact on model performance, and of course, it's very important, frequently neglected end-to-end systems, right? It's not just perplexity of your language model. How does it impact, spell correction or final conversion, right? Continuous assessment, everything, how your models impact end-to-end metrics is very important for all customer or business metrics. Global data changes can go wrong, like changes in global distribution caused by events or seasonal shifts, incoming data quality issues. Maybe your model is correct, but the data is broken, right? You don't want to broke user experience. You must find some ways how to deal with such situations. System performance, uptime, maybe model is better from performance accuracy point of view, but performance of the system degrades. They want to deploy this model or not, right? But internal biases, compliance, fairness of the model, so on. Significant changes in models, how does it affect not just average cases, but outliers? There are some very important outliers, right? So it's very important to build a part of your NLP system, MLOps systems, which can detect many wrong cases and apply proper corrective actions, which can be very different in all these different scenarios. And of course, to all of this, build key services of monitoring, alerting, logging is a key part of building successful NLP system. There are a lot of NLP libraries to help you as you build systems, right? There are all these old good technologies, hidden Markov chess, conditional random fields, SVM, which are developed many years ago, still useful for many tasks, right? There are a lot of libraries for those. New technologies, of course, Hugging Face transformers, invaluable library now, having huge set of different pre-trained models for different cases. Fast text is useful. It's not really deep learning, shallow learning, but quite useful due to performance for many tasks. Allen NLP, Slap environment, PyTorch NLP, Flay NLP, detects from LinkedIn, many other libraries for deep learning-based NLP. A lot of academic open source available, like C papers with code. People publish some paper for, let's say, question answering. And they code, of course, typically not production ready, but you can take and you reuse it, create production ready. Don't hesitate to go inside of open source. I had case with one startups. I helped improved performance of Stanford library, like order of magnitude by proper implementation of multiple threading inside. There are a lot of high-level libraries, not just NLP, but like Rasa for dialogue systems, NVIDIA Yarvis for multimodal dialogue systems, NVIDIA NEMA like for automated speech recognition, for machine translation, Spark NLP, and so on. There are a lot of more high-level libraries which implement a lot of useful NLP use cases which you can use, reuse, tune for your systems. Very important to build proper team, right? It's not just strong science, again, not just strong NLP scientists. Strong engineering, product management is important. Product management is super important. You must understand very well your business, how to map to these new NLP cases, but also must build good connections with your engineering team. So having proper product management is very important for success of NLP systems. Strong engineering, again, build high-performance system, build proper MLOps is very important. Again, a lot of advantage with new deep learning NLP, so it's very important to have scientists which understand very well how to build deep learning-based NLP systems. Build proper engineering culture, ops is also important. Very important to build and reuse, like in your company, data training sense, right? Because you like if multiple, again, NLP useful for many different cases. And typical tendency, each team start creating their case independently in very different departments of the company, and they lose a lot of money and time to create, mark, annotate these cases. If you create reusing environments such that training, testing data are reused across all your teams within your company, it gives a lot of value. It's much faster velocity. You save a lot of money, and also you save a lot of on the quality, since you can focus, some particular teams can focus on quality of training, testing data. Very important to build successful NLP cases in your company. Building proper offline and online metric is very important. Again, people from academic community tend to focus on academic metrics, but what really you care how it affects customer experience and business of your system, right? So it's not just about perplexity of language model, let's say, but about its impact on spell correction model and about final impact on user conversion, which you search through the spell correction model. So building proper evaluation systems for your NLP models, which will measure not just performance of the model itself, but impact of the model on end-to-end quality or your business revenues, profits, customer experience, performance of the end-to-end systems is very important. So building this whole metric systems is one of the key requirements of building successful NLP system. Building continuous improvement cycle, right? So typically for NLP solutions, as for any ML solutions, you don't just build one model, but you iterate a lot of improvement of model in some cases, and gives you a lot of business impact and customer impact. So important to build this improvement cycle such that you have teams focused on some particular use cases. They iterate on quality of models, quality of data, serving these models, quality of serving systems, which improves a lot of customer experience and business value. And understanding that NLP is not just build systems, move to the next system, but continuous improvement of many systems is very important, and building this improvement cycle is very important for success of NLP. Creating proper ROI assessment expenses, right? As you build the systems, there are a lot of expenses such as salaries of people, software costs, compute storage costs, data annotation costs. And like as I said, like you can frequently create small teams moving very fast on some systems that helps. You can move with small costs at the beginning, proving value, and then you can build bigger systems with bigger costs to create these systems, serving much bigger use cases. So this is quite important. There are a lot of libraries to use. So like ROI assessment is very important, and proper understanding like what your system advantages for the business and what its cost is very important to build successful NLP use cases for companies inside business, right? And for some cases, assessment of NLP is direct, right? If you improve customer conversion for e-commerce, you understand how much money you get through a experiment. But sometimes it's much longer impact. You improve customer experience, this customers comes more frequently later. To understand this, you need to build better experimentation systems. So building proper experimentation systems is very important, frequently part of building successful NLP systems. And final conclusion, so building an NLP system is a relatively easy task in 2021 comparing to what was 5-10 years ago. There are a lot of open source libraries, cloud solutions. you can build the systems with high ROI, high return to the business, and there are multiple ways how to do it. Thank you very much.